And thanks a lot for joining the talk. I realized that the title up here in the slide doesn't really match with the program. We've been reusing these slides a couple of times here, but we're essentially going to talk about the results of a very large study we've done in Heyhack on application security. We've scanned almost 4 million hosts out there and have found a lot of interesting things on the internet. So it's going to be a very practical talk. We'll speak about what's out there in the real world, and then we'll dive into some specific types of vulnerabilities, and we'll do some hands-on demos. So it's going to be hopefully very fun. My name is Sebastian, and I'm one of the two co-founders of Heyhack, a Danish startup in the application security space. We've built an automated pen testing engine for web apps. We started last year in January, so we've been going at it for just over 1.5 years, but we're really based on more than 20 years of experience in web application security and testing. We've been working, both my co-founder and I, with many of the competing solutions in this category, Nessus and Qualys and Rapid7, some of them you might know. And we were a little tired of quite honestly, how poorly many of them were working. So we decided to go ahead and build our own engine from the bottom that can handle any modern web app and scan that, crawl that, and find all the functionality fully automatically with the purpose of uncovering different types of vulnerabilities. And we already have a wide range of different customers around the world, including Netcompany and KMD and even Trifork here and many others. We're a Microsoft technology partner, and then we are a proud sponsor of the Open Web Application Security Project. We're a corporate member there. And we've been in the market for about a year now. We launched the product on Product Hunt a year ago in August and became the #1 product of the week and have been inducted in their Hall of Fame. And then finally, we're funded by Pre-Seed Ventures. So that's just a little bit about us. And myself, as I said, I'm one of the two co-founders of Heyhack. I've been involved with the GOTO conference on and off for many years. I used to be a developer evangelist at Microsoft. And back when GOTO was in this Bella Center conference hall, Microsoft even had its own dedicated track there. And so we were a little involved with the program back then even. I've been a .NET developer since 2008. And before that, when I was a teenager, I sat there in my teenage room writing classic ASP and VB script. Built hundreds of web apps and unfortunately introduced more SQL injection issues than I'd probably like to admit. But haven't we all? So today we'll be speaking about the results of this global study we've done. So we decided to figure out how big is this problem of application security? How many vulnerabilities are out there? How many web apps could potentially be exploited? So my co-founder and I, we sat down in the beginning of the year and we sort of designed this study. We found many organizations all around the world and basically started crawling all of these organizations to map out all the host names that they would expose to the public internet. And then we would do some very light testing. We'd just basically be scratching the surface of some of these hosts to try to see if there would be any issues with them. And in total, we've scanned more than almost 4 million domains, which we'll go into. We'll dive into some specific vulnerabilities as well. First of all, we've seen lots of leaks or file leaks that are sitting out there, files that you probably would not want to expose to the public internet. So there's quite some interesting things there. Then there's a specific issue of dangling DNS records. It's a very trivial and simple issue, but the consequences of an attack against this particular issue can be quite severe. So we'll dive into what that is and how somebody might exploit your organization using this. We'll also have a look at vulnerable FTP servers, and even though FTP seems like sort of an outdated protocol these days, it's still very much used out there, and there are a lot of FTP servers that you could go ahead and exploit if you would want to. And then finally, we've got our old friend cross-site scripting, a thing you would think would be solved in 2023. I can reveal that it's not. It's still very much a big issue. And to dive further into that specific problem, I'm bringing a case study with Fortnite. We'll speak of some of the shortcomings in web application firewalls, which is a common solution that people try to employ in order to protect their apps against potential attacks. But yeah, spoiler alert, these web application firewalls are not doing a very good job. I'll speak a little bit about why you should invest into AppSec early on, and then sort of a little recipe for how to get started with application security. So coming into the study here, my co-founder, Anders Skovsgaard, he used to run another company called HackAvoid, which was sort of building on the same idea as Heyhack today. This is in Danish, but these are 2 Danish news articles that are the results of a study that Anders did 12 years ago. And translated here, it says that every other Danish web shops has a serious security issue. Back then, he'd tested around 1,100 web shops and found that many of them, more than half, had severe issues, and even 8% had SQL injection issues. This was a very small study compared to what we've done this year, but even though he wasn't even though the scope of the study was very small, he still got a lot of feedback from people not being super happy that he'd done this scan without asking. He didn't cross any boundaries. He just sort of did the slide scan, but still people weren't too happy about that. This year, we've done a study of almost 4 million services across 103 countries. We've scanned more than 8,000 organizations or companies. We've been running about 200 virtual machines on and off between February and May, so we've put a lot of compute into generating these results. And we've executed thousands and thousands of test cases. And interestingly, this year, nobody responded. So you could sort of think of why that might be. There's definitely sort of a change in, I guess, in the attitude around application security compared to back 12 years ago. Here's an overview of the concentration of the different services here. So it's obviously a world map here, and we've tried to map out where the IPs of these different hosts are located. And as you may know, like IPs are typically assigned to a country. So we can sort of map out here where all of the services are. We see there's a large concentration in North America, in Europe, or Western Europe at least, in Brazil, China, India, and Australia, and also some in other geographies. We've tried to find known vulnerabilities, and known vulnerabilities are typically scored on this scale called the Common Vulnerability Scoring System. So a score between 0.1 and 3.9 would give an issue sort of a low severity, between 4 and 6.9 medium, 7 and 8.9 high, and then between 9 and 10 it's critical. The way that this scoring system works is that you set some different parameters in order to assess the severity. So for example, can you exploit a given vulnerability over the public internet, or do you have to be physically present next to the server? Are there some requirements there, or do you have to be in an internal network? Obviously, if a vulnerability is exploitable on the public internet, it's more severe because anybody could go ahead and do that compared to an issue that you can only exploit if you're actually standing next to the physical server. That might be a little more difficult for a person to do that. Do you need a user or sort of an innocent user to do something? Do you need to trick that person into doing something? Maybe combining a specific vulnerability with some social engineering. Again, that might require more effort, and that would lower the severity as opposed to an issue that could just be exploited directly. So the NIST, this in the organization in the US, they have this calculator where you can basically set the values for these different parameters, and ultimately it's going to result in a score. And this score is commonly used to prioritize the importance of different issues. There is a public database called the Common Vulnerabilities and Exposures Database, CVE. It's a database that's maintained in part by NIST, this American organization. And here you can see some examples of vulnerabilities that have been found throughout the years. Typically they get a number, so CVE dash, and then the year the issue was found, and then the number for that year. So you can see different issues here found in IBM WebSphere, in ProFTP. We're going to dive a little more into that in McAfee's Web Gateway, and in Oracle Application Server here as well. I'm just going to make sure this is not going to fall off. You might also have heard of a very big issue this year in an application called MoveIt. It was a file transfer service, a web-based application where you could transfer files in and out of a corporate network. Being based on a web app, they had an SQL database running in the background, and unfortunately, it was found that this MoveIt application was vulnerable to an SQL injection attack. And this has been exploited very much by a hacker group out there. So I think more than 600 organizations have now been compromised, and lots of data has been leaked, including driver's license databases in the US and many other things. And that particular vulnerability, being a vulnerability in a known piece of software, move it, has then gotten this number, and this is sort of how this system works. We can then again take a look at sort of the concentration of different issues, and here we've taken all of the issues that have a severity score higher than 7, and then we've seen where is the concentration of these issues around the world. And I would say looks like we're doing pretty well in Scandinavia here. Like, it's not as bad as you could have feared. Many places sort of in the developing world, including Mexico, Peru, and Argentina, Eastern Africa there, and to some extent China and also Iran, we see that there's a larger concentration of these types of issues. If we lower the threshold a little bit, so we say, hey, if we just want to look at issues that have at least a medium severity score, the sort of distribution is a lot more uniform. Basically, we find these types of vulnerabilities all around the world. And in conclusion, about 3/4 of all organizations have a severity or an issue with a severity higher than 7. And you can kind of use this 7 sort of as a guideline. If it's higher than 7, you need to do something about it right now. And if we lower the threshold to 4, it's about 80% here. So a particular type of vulnerability might be file leaks. And we've seen many interesting things out there, including source code, passwords, private keys, configuration files, and database backups. There's a lot of interesting stuff out there if you dig a little bit. And we found that 29% of all the organizations that we were testing during the study have leaked some sort of data out there. This is a surprisingly high number, if you ask me. And here we've taken some screenshots where we've obviously masked the victim here or the target. So in this case here, we found a file called backup.zip. Very naive, you could say, but this particular file included a bunch of source code, in this case here in .NET. We also found configuration files with raw strings to databases, including passwords, and as I said, some source code out there. Probably not the best thing to leak in a backup.zip file in your root. We've also found, more zip files here, including certificates, including the private key. We've also found raw SQL dumps that define both the structure for database and the data itself. So this is a full backup of a database. And as I said, web config files here, where we've not only found database connection strings, but also API keys to third-party services like SendGrid, which is an email sending service. So there's a lot of stuff out there, more than you'd think up front. Again, looking a bit at the concentration here, we see that this problem is more or less uniform across America and in Europe. So there's not really anything that points in the direction of a specific geography having this problem more than others. And there's a good chance that, unfortunately, your organization might suffer from this as well. Another problem, which is extremely common, is the problem of dangling DNS records. And this is probably one of the simplest issues, but also one of the most dangerous ones. So in many organizations that adopt the use of the cloud, either Amazon Web Services or Microsoft Azure or Google Cloud Platform or anything like that, developers tend to be very quick at spinning up resources, a new website or a virtual machine or whatever it might be, and they're going to ask their IT department for a DNS record from their corporate domain pointing to this resource that they just created. That's all cool. You get a nice-looking host name from your corporate domain pointing to the server you've just set up. The problem then is when you shut down that server again, and we find that many organizations are actually pretty good at cleaning up their cloud subscriptions. They obviously don't want to incur the cost of running a server that's not being used any longer, and so they'll shut down that server pretty quickly. But many people tend to forget to remove that DNS record. And by having a resource in the cloud that's either hosted on an IP owned by Microsoft or by Amazon or Google or anybody else, or even a host name that somebody could just come in there and set themselves if they have a public Azure account, well, you suddenly open up yourself for a subdomain takeover attack where anybody that has an Azure account or an AWS account could go in and create the same resource. And so I have a little bit of a demo of how it would work in practice here. And this here is a screenshot from Microsoft Azure. They have a very great service that is typically one of the biggest targets called Azure Websites here. And so Microsoft will happily give you a nice looking host name for your new service. In this case, we're setting up heyhackdemo.azurewebsites.net. That looks cool. We can publish it any way we'd want, either by uploading code or by supplying a Docker container. And in a matter of minutes, we'll set up a website here that on that particular host name. We might want a nicer looking name though, so we can come into our DNS zone here, either ask our IT department or go in and do it ourselves. And we could set up a subdomain here, demo.heyhack.com, pointing to our new website here, heyhackdemo.azurewebsites.net. And within, again, a matter of minutes, this should be out there, and we can navigate to our own site, to a new site, and we're all happy about that. And that looks great. Now, the problem is that a month later or 3 months later, you realize that you're not going to need this site any longer. It might have been a dev site or a test site, or sometimes marketing is at fault. Marketing divisions tend to spin up campaigns all the time. They might also ask for a subdomain, and so they'll point that subdomain to a resource, but after 3 months, the campaign is not running any longer, so they'll shut it down. And so they'll come into their Azure account, they'll go in, they'll delete the resource, but they'll forget to remove this record. And now, anybody that has an Azure account, as I said before, could come in here, do exactly the same thing. Azure does not, out of the box, protect against this particular issue. You have to take an extra step and set another record. That is supported by Microsoft, but many people tend not to set that. And so you basically open up yourself for this type of attack where anybody can just go in and create a resource. And when that, when people do that, you can imagine what kind of content you could put on a reputable domain's subdomain here. And in this case, these are real examples from the real world. Indonesian gambling sites taking over Scandinavian companies, including very large telcos in Denmark and some manufacturing organizations as well. We've met a surprising amount of very large organizations that just don't have this under control. And in this case here, the attack might be it's not as severe as it could have been probably. In this case here, the attacker is basically just trying to direct some traffic over to their dodgy looking gambling site in Indonesia here. But you can imagine something far more serious if somebody were to make a targeted attack against a certain telco that might have this issue. You could imagine that they would style this page to look exactly like the branding of that telco, and you could create a little login form and try to trick people to type in a username and a password and harvest some credentials that way. Another problem might be or another issue might be that of cookies. So if you own or if you control a site that's running on a subdomain where some other cookies are being set, if these cookies are not protected by host only and HTTP only, they might be retrievable from these other sites. So there's a chance that you could go in there and read out session cookies for other applications on the same domain if you trick a user to come into your site. So there are many types of attacks you could imagine here. Moving on to another issue, FTP servers are always fun, and particularly ProFTP 1.3.5 if you've got the file copy module installed. And this is pretty severe because if you got that installed, you basically allow anybody to come in there on your FTP server and upload and download any files they might like, even without authenticating. We found that 2.4% out of the 3 million hosts have an FTP server running. 13.1% are running ProFTP, and 7.9% of all ProFTP instances have this particular vulnerability. And in total, around 1.5% of all the organizations that we found have this particular vulnerabilities. That's a little over 100 organizations that have this massive problem where people can just come in there and up and download files and execute code remotely and all of that. I think that's pretty severe. So I have a little demo of how you might exploit this. In this case here, we're connecting to the FTP server using Telnet. So you've got a terminal on your computer. There's a good chance that Telnet is already going to be installed. And so the way that you would exploit this would be to come in and say Telnet, type in the vulnerable host's host name, and then 21 for FTP. And you're going to get this welcome banner saying, hey, welcome to ProFTP 1.3.5. And you can then type in this command called site help. You can see all of the different modules that have been installed. And what we're looking for here are cpfr, copy from, and cbto, copy to. These two commands will only be there if the file copy module has been installed. So now we know we've got a good grasp or a good hook on this particular server here. And so what we might do would be to copy a file locally that we've created, where we basically just type in this little PHP script here. And PHP has this fantastic method called pass through that will just pass any command through to the shell that runs the PHP instance there. And so what we're doing is we're sort of extracting the value of the RCE query string parameter here. And that's what you do with the $_get. And we upload that to the server with the copy to command. And that's great. Now the copy has been successful. And now we can go ahead and just issue a simple GET request to this particular file, attack.php. So the attack might look something like this: vulnerablehost.xxx.com/attack.php, and then the query string parameter RCE. And after this equal sign here, we can type in any shell command that we'd want to. And you can really imagine all the kind of damage you can do from here. Again, moving on to our good friend here, cross-site scripting, one of the biggest issues in web apps globally. We found that 4% of companies have a service with a known cross-site scripting issue here. I'm saying known because we're only looking for CVEs that cover cross-site scripting. So known servers that have a particular CVE where cross-site scripting is present. That might be a WordPress plugin or a module to Nginx. Keycloak is sort of an open source identity provider. It has a problem with cross-site scripting before version 8. There might also be Drupal plugins and so on. The core, if you're not familiar with cross-site scripting, the fundamental issue is that you can execute JavaScript in another user's browser that you've created, basically. So it's kind of the idea of cross-site scripting. So you might have a search field, for example, where the query that you type into this search field is going to be represented again on the search results page. That's the case on the OWASP view shop, target shop here that we're going to take a look at in just a second. And by representing the query again, that if you're not escaping for HTML characters, you might be susceptible for cross-site scripting attacks. And let's just have a look at that. So we'll just go into our instance here of the Juice Shop. If you're not familiar with this application, it's one of the flagship projects under the Open Web Application Security project. The authors themselves say it's a modern and sophisticated application, which is probably the most insecure in the world. So, yeah. So the developers have on purpose implemented all kinds of issues, including SQL injection, cross-site scripting, cross-site request forgery, and basically every problem you could imagine in a modern web app. And the problem here is that there's this little search field here. And as I said, if you type in a query, we could just say, oops, I will have to just switch over. Hopefully now. Yes, good, thanks for that. So if I type in GOTO CPH, you can see that this is being written here again. And now we might be onto something, right? So what we try to do would be to just create a bold tag and say 1, 2, 3, and see if this renders. And it does, and you can kind of see that this is bold and this is not. Okay, a bold tag might not be the most interesting attack. We could try to do something a little more fun. We could try to close some HTML tags here and type in an image tag. We're going to set us, or we're going to type in the source attribute here, but we're not going to set it to any value. So when the browser tries to load this image, it's going to find that there are no image source. That's going to throw an error in the browser, and we can then create this on-error event handler. And here we can execute any JavaScript that we'd like. And so we could just say hi GOTO here. And if we were to execute this, you see that we get this little JavaScript alert box. Now, this is enough to demonstrate that you sort of got control of this application here. You could type in some other commands. So rather than just saying hi GOTO, you might type out the document cookie. So let's just try to do that. Document.cookie. And now you see all the cookies that have been set on this domain here, including some continue code that looks a little funny. So if your cookies on this domain have not been set to HTTP only and host only, you could read out any cookies, including session cookies here. Instead of just displaying these cookies in an alert box, you could send these cookies with an XML HTTP request over to a server that you might control, and then start harvesting these session cookies, and then use that to impersonate users and maybe do something in their accounts. So it's a pretty severe problem, as you can imagine. I've got a little fun tool here that I'm going to show you as well, called the Browser Exploitation Framework. This is sort of a POC hacking tool. It's called Beef for short, and it's based around cross-site scripting. So if you found a target that is vulnerable to this type of attack, you can do a lot of fun things here. And in this demo setup here, they've got this demo page, which I have here over on the right-hand side. And on this demo page, well, it's already hooked into to Beef, so there's a piece of JavaScript that's being executed that hooks in that browser. If you can't, well, in most cases, you won't be able to actually change the source code of the application, but what you could do instead would be to copy this little link, and this link here includes this little JavaScript function encoded as, or it's the URL encoded. And if you're familiar with JavaScript or any other programming language here, you can see that we've got this URL. You will have your host or your script setting on some domain, so mytarget.com or whatever, on some port. This hook.js script is going to hook in the browser into Beef, which allows us to do a bunch of fun things that we'll see in a moment. And you can see here, if Beef is not already defined, it's just going to go ahead and create a script tag, paste or set in the URL, and append this script tag to the end. Did it shut down, or is it okay? Okay. Cool. So this is basically what it is. So if you found a place where you can execute JavaScript, like you can right here, you can basically start attacking the user here. And let's see what we can do in Beef then. First of all, there's a built-in event logger and key logger, so you can just type in test, for example. And if we were to click into the browser that has been hooked into Beef, we can try to make this a little bigger, go into the current browser and see logs, and you can see that the user typed in test here. So all of these events are being logged automatically. You could also do something that's a little more fun. You could try to execute JavaScript on that page. So I'm just going to make this, can I make this a little smaller? Okay, so here there's this function here where you can basically execute any JavaScript in the target or the victim's browser now. So in this case here, we've just got this little sample, alert Beef raw JavaScript. We can say run this, and over here in the victim's browser, you can see that this is suddenly popping up. This might be a little interesting for the victim that not interacted with the application in any case or in any shape or form, but still suddenly this alert box pops up, right? You could do something that's a little more fun than that. You could say, instead of saying Beef draw JavaScript, again, we could type out the document cookie. We can do that again, and we could say execute, and boom, now we've got the cookies here, and just before this, I set a little cookie called conf equals to GOTO conf. And then we've got this Beef hook session token here as well. Instead of displaying this to the victim, we might be interested in capturing this. So instead of just saying alert, we could say return document.cookie. And if we say execute here, let's see, you can see that the results are being displayed directly in the attacker's little terminal here. So it's a pretty fun tool. Other than just running JavaScript, there are also these built-in interesting kind of social engineering attacks that you could run, including this Google phishing sample here. And in this case here, we can navigate the user's browser to a page that looks very much like Gmail. So if I click execute here, we can see that the victim's browser has now suddenly navigated to something that looks like Gmail here, right? And if this is sitting maybe in the background of the user's PC, maybe it's a tab that you don't have active right now, you might not realize that you were actually on a different page before. Suddenly you're now on the sort of the Gmail page here, and you might think, oh yeah, maybe it's time to check my email, and you could type in your credentials, and now it's working again. And click on sign in. And if we just move over to the other browser here, we can now see that this command executed successfully, and we get the credentials here as well. So there's a lot of things you can do if cross-site scripting is there. Like you've basically got full control of the entire browser of the victim there. There are some more fun ones that you can maybe play around with in your own time if you'd like. Let me just try to see. I think there is this way where you can enable the. I forget where it is. It's kind of like organized into these different categories here. There's a way where you can enable the webcam as well. That might be very interesting, and see a live video feed of your victim if they accept it, of course. So the browser will put in this little protection, asking if it's okay to enable the camera. But some people might do that, and then you can see a live video feed of your victim as well. So pretty interesting. I invite you to go ahead and have a look at this project. It's pretty cool. Coming a little bit back to the presentation here, we'll have a look at what this might be used for in real life. So there's a case study here using Fortnite. Some of you might play Fortnite, or maybe you have somebody in your family that plays this game. They had an old web app sitting on the same domain as all of their other applications. So on epicgames.com, they have their sort of account management side, and they've got this virtual universe where you can buy this virtual currency for your character in Fortnite. The issue is that Epic Games over the years have also built some other games and some other tournaments that still sit out there and that haven't been maintained for a very long time. And in this case here, there was a research group at Checkpoint Technologies, an Israeli network security company. They found this old web application sitting out there that was hosting some results from some competition that had been going on, I think, quite a number of years ago. And they found this particular endpoint that turned out to be vulnerable. So index.php, stats equals to maps. And then there was this search query field, a search name, that kind of worked the same way as we just saw on the OWASP view shop there. So any query you would type in here would directly be represented or shown in the UI of the user. If you want to look into this, there's a whole video about it. And as I said, Checkpoint, they made a really good write-up for this particular attack. So if you want to learn a little more about this, you can go ahead and do that. But essentially, they found this application, U2 2004 stats. And I guess even from the UI, you can see that this has probably not been built within the past couple of years. It looks a little outdated to me, right? And so here, let me just try to see if I can use the pen. So up here, it might be, oops, I'll try to redo that if I can, or not. Well, hopefully you can see what I've tried to highlight here. So they've tried to put in this unmouse event, and just immediately after that, they've done exactly the same thing as I did before. The %27 is an apostrophe, and then they've got XSS for cross-site scripting there in the middle. And so when you mouse over this particular event or element that is vulnerable, you'll see this JavaScript alert box. That might be a little funny for the user if they see that. They found another type of issue, which is not an issue in itself, but combined with this cross-site scripting, they were able to exploit it. They were using social logins such as Facebook and PlayStation Network and Xbox Live and other login providers. And they would then provide this redirect URL whenever they would send over the user to log in on Xbox Live or PlayStation Network, for example. That service would then redirect the user back to a URL here. And in this case, the researchers found out that they could put in any host name here as long as it ended with epicgames.com. And so what they did was that they used this vulnerable application, UT 2004 stats.epicgames.com, and they just pasted in a little script here that they created on their own in this search name parameter. And if you take a look at what's here, it says script %20 is the URL encoded version of a space, then the source, and then the source then points to a script that's hosted or that's hidden behind this bit.ly link here. And the reason why they had to use this bit.ly service was that they figured out if they typed in a very long URL, the web application firewall that was sitting in front of this application would automatically block this particular request. But by simply shortening the URL using the bit.ly service, the web application firewall was bypassed. So that was one of the weaknesses of a web application firewall, and we'll get more into that in just a moment. This particular script, or this particular file that was hosted behind bit.ly hosted this script here. And there's basically this little function that they created that extracts account tokens. And then they've created this little XML HTTP request class or object here, and made a request to a server that they hosted on their own PC. They exposed that service using ngrok, which you might know of as well. It's basically just a service that allows you to take any local server you've got running on your PC and get a public host name. And they made this little script here called savecode.php, and it basically just took whatever code that was sent via the post request and saved that. And if you look at the other end here, this is what it looks like for the attacker. They obviously control this safe code server here, and here you can see a code coming in from a victim that's not obviously aware of this particular problem. And using this particular code, they were then able to impersonate that user, log into their account, buy these V-Bucks, I think that's the name of the virtual currency in Fortnite, and basically do all kinds of things with that person's account. So pretty severe. And speaking a little bit about web application firewalls, I'm just mentioning this because Checkpoint themselves, in their debrief, spoke about some of the weaknesses and how you could bypass a web application firewall. And we've been then looking at a very large vendor of web application firewalls out there to test whether they are efficient in actually protecting against some of these issues that we've then gone through now. And we've been testing using the OWASP UShop with and without a web application firewall. So in this case here, we set up this WAF on an instance or a virtual machine running in Azure, basically redirecting all requests to the UShop that we had sitting on this IP right here, but obviously trying to protect against any attacks in the meantime. And we started out pretty simple. We tried to trick the web application firewall into thinking that we were doing an SQL injection attack. And you might know that both of these two keywords, union and select, are some common SQL keywords. And we found that this particular vendor of this web application firewall thought that just these two words were enough to sort of pose a threat or pose an SQL injection attack. It's obviously not an attack on its own. Like, these two words are pretty benign if you don't type in any other type of query. We've been testing the search functionality here on the UShop, and you can see that with the WAF, we got this response back saying that the attack was blocked by the web application firewall. But without the WAF, we get this research results back here. Now, the problem with this is that the web application firewall in this particular case had built in some static generic rule that just protected any type of request that includes these words. But there's a really big risk that you might reject genuine users if you do that. And so I just created this little example here where we've typed in a piece of text into this customer feedback form. And I just invented something that probably doesn't make a lot of sense, but it was enough to sort of trigger this issue. So you can see that I've typed in Joe Biden gives a speech on the state of the union, and the American people have chosen to select him as president. Hardly an SQL injection attack, right? But still, the web application firewall thinks that it is. I'm pretty sure that if you set this up, the business owner of this particular app is going to go and tell you to turn it off because it's sort of hurting the performance of the app and real users can't use it. On the other hand, it turns out to be pretty easy to bypass these rules whenever you actually do a real attack. So in this case here, we found that by sort of escaping the apostrophe there, so I can basically, so this is sort of the URL. What's in this orange box here is the decoded version of what's in the URL right here. And a typical SQL injection attack, well, you'll try to break out of the query and invalidate the where clause by just saying 2 equals to 2, which is obviously always true. And then the filter that the developer has put on is not going to be valid any longer. And it turns out for this particular web application firewall, inserting 2 null bytes, which in a URL encoded format looks like this, %00, and then a random character afterwards, you could just bypass that specific rule. So the protection against SQL injection here was totally invalidated. And so in this case here, you can see that if you just use the endpoint and you search for a banana, the juice shop here does have a banana juice, so it's going to come back here. But if you type in this constructed query where you have these 2 null bytes here, you'll basically get out all of the products, the workhorse is basically invalidated, and that lets you get full access to the database, really. So what can you learn from that? Well, web application firewalls can maybe do something. They're not going to save you. It's much, much better to go ahead and fix the actual issues in your application. And that's why you should probably think about investing into application security very early on and really embrace that idea of shift left testing, where you don't leave security or you don't work with security as an afterthought, but rather you think about it when you actually start the developing of the application. It's actually not that difficult. It might sound like a sort of a big task or a big job, and it's going to slow down your development. But if you do it the right way, it's not going to be that big of a hassle. So, I mean, I've got some statistics here. 60% of companies that did invest into proactive measures were able to detect a breach, versus 14% that did not invest could detect a breach early on. So there's some advance or like some benefits related to that. IBM has a pretty interesting report that they frequently update. It's called the cost of a data breach. And the cost of a data breach is, I don't know if it's surprising, but it keeps increasing. So an average data breach is going to cost $4.5 million. And that amount could also be reduced if you actively or proactively invest into this. There's also the issue of reputation, of course. I mean, even if the breach itself that you experience is not going to do that much harm in itself, there's a reputational damage, and KPMG obviously finds that most customers that do business with a company that has experienced a breach will leave that company after the breach. You can prevent downtime and disruptions, and finally, you can also future-proof your application. Here's some some takeaways that I think you should really try to think of, like when you come back and get back to your jobs maybe next week. I think you should really try to map out your external attack surface across all the domains that you have in your organization. And so the first thing would maybe be to list out all the domains that you know you've got, and then figure out which services are running here. You can use some commercial solutions like our own for that. We have a pretty good solution to cover all of it. Or you can use one of the open source projects under the Open Web Application Security project, OWASP. They've got a project called AMAS, which is pretty good as well. Then the first thing is you should really try to clean up your DNS records. As I showed before, many of them are sitting out there, they're dangling, and it makes you very susceptible or very vulnerable to subdomain takeovers. You should also do the effort of updating your web servers. That might be a little more tedious, but there are some serious issues, particularly in Apache, that just continue to be found by people out there. And it's a very important thing to keep these updated. You should set up continuous tests of your applications. There are many types of tools that can help you there. There are tools in the static application security testing category, SAST, such as Snyk or SonarSource or Veracode or Checkmarks. There are a few in that category. And then there are the dynamic application security testing. Basically, the difference is that SAST tools will look into your code and try to find any issues at compile time, where DAST tools will try to find issues coming from the outside. And we ourselves are in the DAST category. You should work with your developers and integrate these testing tools with their development tools. So many of these testing tools will let you integrate with their development or CI/CD pipeline. So whenever you go ahead and make a build or a pull request, you could go ahead and run a test as well. And then if there are any issues that have been found, you could qualify that issue and maybe bring it back into Jira or Azure DevOps or wherever you're working. You should then retest that the applied fix actually provides the correct type of protection, and then continuously test that you're not introducing some issues again. We typically find these regression issues quite a lot. And then rinse and repeat. That's really the recipe that we've got for you here. So I hope this was more or less useful, and I'm sorry about the AV problem here. I hope you caught the middle part as well. And if you've got any questions, we've got about 5 minutes that we can do here.